In this video, I break down the solution for challenge number 10, reentrancy of Ethernaut CTF. So this video is part of a series of videos solving all the challenges in Ethernaut CTF. So if you like this kind of stuff, you're in the right place. And I also explained the reasoning behind the solution so that anyone can understand it and do it themselves. So hello and welcome to DecentraWise channel. My name is Pedro, and in this channel we share all things Web3 development and security and blockchain. So if you like this kind of stuff, you are in the right place. So let's go on to Ethernaut CTF, and this is the website of Ethernaut challenges. And if we are connected with MetaMask and on Sepolia network, and it's a test net. So if you want to know how to set this up and get all things configured, head to our first video in this series where we explain all that. So we need to open the console in the browser to interact with our challenges. So let's go on to our challenge number 10, reentrancy, and we click here, and we have our instance, our challenge open. So we get let's see what we get here. The goal of this level is for you to steal all the funds from the contract. This is a fun one. So things that might help us. Untrusted contracts can execute code where you least expect. That's true, right? We should have also understanding of fallback methods. That's okay. Throw revert, how things work, and sometimes the best way to attack is with another contract. We know that already. So let's check the code for our challenge. So our contract is using Solidity version 6 and safe math for Win 256. That's a regular thing. It's making use of the add function of safe math. Sounds good. So we have a mapping of balances. Sounds fun. Okay. And when we call donate function, we can send a value to it. It's a payable function, and the value will be added to our balance. Sounds good. And we have a balance of that tells the balance that we have in the contract. Fine. And we have a withdraw function, and that withdraw function receives an amount and checks if our balance is greater or equal than the amount that we want to withdraw. Sounds okay. Then we call the amount to our sender, right? And we update the balances, and we have a receive function, and that's it. So if someone sends Ether to this contract, it will stay there. Okay. So everything looks cool, right? But it's not. So what's the problem here? This is a standard reentrancy vulnerable function. So the problem is that we update the balances after sending the value. So if this is a generic account or a EOA, which is an external owned account, everything looks fine, right? We send the value back and we update the balances. But the problem is that this message sender can be a contract, and in a contract we can have a receive function that actually gets called with this call, right? So, and in that function, we can do whatever, even call withdraw again. So what does this mean? This means that we can loop to drain the contract with the receive function. And that's what we are going to do because we can and we love draining contracts. So let's do it. So let's get our instance and confirm in MetaMask. Boom. And we have our instance to play. Instance, it's this, the address of our instance. And let's go to Remix IDE so that we can have a contract for this challenge. So let's create a new file, reentrance.sol. There we are. And let's put here the code. Okay, we don't need, let's just do it 0.0, and we don't need this. And let's just change this into an interface just because we can. And we don't need any of this. We have a donate function. We have a balance off function that returns the balance. And we have a withdraw function. And that's it. Okay, external. So there we go. We have our interface so that we don't have too much pollution around here. And now we can create our contract. Contract, reentrance, attack. There we are. And in our contract, what will we do? So we need to have our victim. So, and we know that it's of type reentrance. So reentrance victim public. There we are. And we need to send an amount to this contract so that we can exploit. So we will have to attack this by donating a value so that we can actually withdraw, right? And pass this check. If we pass this check once, we can pass it all the time. So let's do that. So we need to send an amount and to the donate, and then perform the other stuff, the withdrawal. So let's start by having a constructor, and this constructor receives the victim address and sets it. We need to put reentrance in it. There we are. Let's store the amount as well, because we need to know how much we need to withdraw. So uint 256 public amount, okay, and amount equals to message dot value. There we are, and this needs to be payable. There we go. And now let's do our attack function. Function attack. There we go. External. And the first thing that we need to do is to donate, right? So let's do that. Victim.donate to us, this address, right? So we donate to ourselves. Which amount? Value, amount. So we send the amount that we received in the deployment to the contract. That's it. And now we do the withdraw, right? So we do victim.withdraw, and we withdraw amount as well. So we withdraw the amount. And since we want to drain the contract, we don't want the funds to get stuck here. So we will send the funds to our back to our caller. So we can get the money out of the contract, not stay here in this contract. So msg.sender.call value this balance, and we call nothing. Okay, so we are sending the balance back to our caller, so the account that calls the attack function. Okay, so this is just for us to get the money that we are draining from the contract, do our own and the rest of it, right? So half of the attack is done. The next half is actually the receive function. So we need to create a fallback receive function. So receive and external payable, right? And in this function, we want to drain the contract. So a good way is to do a while and address victim.balance. So while the balance is greater or equal to amount. So while this is true, we will be doing stuff. And what is the stuff? We will withdraw again. So victim.withdraw amount. That's it. So what does this mean? This means that we will withdraw our amount that we sent back. And when we receive it, this function will be called and we will check the balance. Is there anything more? And if it is, we will do it again and again and again and again. If there was a lot, then probably we will have to implement other checks too, so that we wouldn't get out of gas. But in this example, I don't think that there will be a lot more. So we are good to go. So I think this is cool. We are not checking the return of this function, but we don't have to. And because we don't need it, it doesn't matter. And yeah, this is it. So let's check what's going on in this contract. Let's check the balance. Await, get balance of instance. So we have 0.001 and we need to perform this attack. We need to send 0.001 as well. So let's do that. Let's first, I don't want to type all the zeros. Let's do another thing like Web3 balance instance. There we go. We have our value with zeros so that we don't have to count them all. Let's copy this. So right now we go to deploy our contract and we have to send some way here. So we can just paste that value of way here. And we need to check that the right contract is selected. We need to connect to our MetaMask. There we go. And now we need the address of the victim. So we need to copy this and put it here. There we go. So we are sending the right amount. Let's deploy and confirm in MetaMask. And we did it. We have our reentrancy attack contract here. We should have a balance of 0.001 ETH. Perfect, right? So we have the right amount to pass this check. And if we pass this, we will pass it again and again and again through our reentrancy attack. So let's do it. So we have the balance here. Let's check what is the result of our attack. Confirm in MetaMask our attack function, and boom, we have the attack done. So our contract is zeroed, no balance anymore. So let's check what happens here. What's the balance of our instance? 0. And so we got our money back and plus the rest that was in the contract. So I think we were successful. Let's check that out. Confirm in MetaMask. And there we go. We were successful. So this is a very simple reentrancy attack. As you can see, we are just doing a while and draining the contract. So be very careful with this kind of function, right? Withdraw needs to always update the balances before the call. If that was the case, the reentrancy attack couldn't work, right? Because this will generate a call back to the contract that is sending the request to withdraw. and we need to always update all the state in our contract before any external calls. Okay, if we don't do that, our code is vulnerable to reentrancy. Okay, that's one way of solving this. The other way is to use reentrancy guards. OpenZeppelin has a bunch of them that we can use, or there are a lot of other alternatives as well. So keep that in mind. If you are not sure of how to do it or to prevent reentrancy, it's always preferable to use a reentrancy guard from any library like OpenZeppelin or some other. Okay, so this is it, guys. It's a very simple reentrancy attack, and we exploited our contract and were able to drain it. And unfortunately, this has been done in real life with millions of dollars, and it still is a very common attack today. So I hope you learned how to prevent it and how to attack a contract that is vulnerable. Of course that this is not the idea of this challenge is not to create hackers to hack more contracts. It's exactly the opposite. So that developers understand how things can be exploited so that they produce better code and don't create contracts that are vulnerable to these situations, right? So I hope you learned how to prevent this and how to attack in the challenge of Ethernaut CTF. And if you got value from this video, it's the regular thing. Smash that like button. It's free and it's there just waiting for you. Go for it. And subscribe for more, because we are sharing all the time videos like this in this channel. And thanks for watching, and looking forward to see you in the next video. Cheers. Bye-bye.